This is just a separate little note about speeds of functions. Basically, at infinity, different functions have different speeds. Wow, what a revolution, right? So the idea is, if you know the speeds of functions and you know their differences, it will help you to be faster. I have the notes in modules, but it will help you to be faster with calculations of limits. Again, remember, only at infinities, even not minus, because exponential at minus is not exponential, function at minus infinity is not infinity. So speeds are: log is the slowest one, linear functions, polynomials, exponentials. Let me show you the idea here. Speeds of functions. Let me write down slowly with you. So logarithmic function is the slowest one. That's what I told you. It's used to slow down functions. That's how cool it is. So even linear functions, even something so simple as y equals x is faster than log at infinity. Isn't it cool? But anything like x squared minus 5, still faster than log. Then we're going to find, polynomials go after that. I usually put them in one thingy, but it's okay. Polynomials, so x squared plus 5, x cubed, they are faster than linear. Usually they merge into one, but it's fine. After that, we have exponential functions. We just learned them. So even a to the 7, y equals a to the 7 is faster than y equals 1000 x squared. It's still a to the 7 is still faster. What is a to the 7? 7 to the x. Still, exponential is faster at infinity. At minus infinity, exponential is 0. So not at minus infinity. Yeah.
What about if a is less than 1?
Yeah, if a is less than 1, we just had it in our thing. It's all reversing then, right? If it's y equals 0.3 at x, at infinity it gives you 0, but minus infinity goes to infinity.
But so in this case, when we say exponentials are faster, but it's still high if a is less than 1.
I guess you're right. To make better notes, let's have a bigger than 1. I wonder if I have it here. No, yeah, very good. I should make this note. That's for a bigger than 1. Good point. Thank you.
What if a is less than 1? Where would it?
It will be very fast going to 0. So it's fast. That's actually a good question. Exponential function is very fast, no matter what it's doing. So it goes to 0 fast and it goes to infinity fast. So it's definitely faster than other functions. But now it's not that obvious what it's doing around 0, for example. Around 0, exponential function is not even 0. So that's also interesting. Then linear function goes to 0, while exponential does not, and so on. So we only talk about infinities, and in this case, plus infinity, since exponential at minus infinity is 0. So there's more to that. We're just not gonna go more farther than that, but there is a function that's faster than exponential, and you heard about it. Do you know it? What other functions do we know? Let's not talk about tricks. They're always weird and tricky. Factorials. Did you get? No? Yeah, good job. Factorials and factorial. We're going to do them in Calculus 2 class, in the middle actually. For 5 years, I was saying 7 factorial, and finally students were brave enough to tell me that it sounds weird. They only were brave enough to tell me in Zoom, because it was 2020, and in their headphones I would say, let's calculate n plus 1 factorial over n factorial. And finally, someone on mute, a very humble student told me, Professor, the way you're saying it's a bit weird. I was like, nobody ever told me that before, and why nobody said? They were probably afraid. So I said, you should tell me how to tell it, because in my language we call them factorial. And there's no problem in my language, for obvious reasons. And they said, well, people started discussing. It was like a whole big deal how to teach me to say this word. They said, you should slow down. Maybe it will be better. I'm like, okay, factorial. The chat in the Zoom blew up. It blew up saying, no, she made it worse. Why did you tell her to do that? Like, oh, I'm so sorry. No, it made much worse. So they agreed that was a bad idea. And then they told me it's an apple, factorial. So it took me, since 2020, I was practicing this. And finally, I switched the habit. But now I tell it as a joke. It's a nice joke. But it took me, I think, 1.5 years to switch. It's very hard to switch habits, especially if you know it for 10 years. It's factorial in English, but factorial in Russian. Because you know what factorial is. And so this one is faster, surprisingly. There is a function faster than that, and you learned it last week. Isn't it fascinating? You learn it. X to the x. Input to the input is the fastest one at infinity, because million to the million is freaking fast, factorial fast. Here's the graph for you. Yes, you can have my note. You don't have to copy this, and you don't even have to know it. But to be honest, for STEM people, we expect you to know what is y equals x. This is what y equals 1. It's slow at infinity. Log, here it is, linear function. Well, y equals 1 is not changing, so that's kind of a dumb example, to be honest. So we're starting with log. It's the slowest one. Y equals a number, not 1, is faster. Log, oh, then it's like we skip n log n, we don't need that. Polynomial is faster. Exponential, 2 to the x, 5 to the x, super fast. And then it's not even compared to these two. And factorial, n to the n or x to the x. Look how fast. So again, going to the infinity, and infinity means going up, right? Look how exponential function always described as a rocket. It starts slowly, so I'll show you exponential function. It starts slowly, and then it shoots up like a rocket really nicely. That's exponential for you. Look at these two guys. They go right away. They don't wait, because 10 to the 10 is already a big number. Guess what? 3 to the 3 is already a big number. 7 to the 7 is a big number. So that is the best one. And 7 factorial, if you don't remember. Do you know what factorial is? And factorial is, and well, I start with 1 usually. Depends on the book. 1, 2, 3, 4, blah, 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 times n. It's a product, ordered product. So with this in mind, can you tell me really fast the answers of these questions? You can. Let's see. Only at infinity, though. If I put 0 or if I put 2, that's not going to work. At infinity, find the leader of each side. The leader of the top is what? X to the 15 is the fastest. We can ignore everything else. 50 is a constant. Minus 3x is a line. Who cares? X to the 15 that's the one. The bottom has a leader 2. Which one is it? Who wins? The bottom wins. The answer is?
0.
0. Because we have the case of infinity. It's infinity over infinity, and at some point, this is my notation. Top and the bottom is not professional. It should be numerator, denominator. I was criticized by this. But it's visual. Visual learners like to see top and the bottom. Bottom wins. So the bottom part grows faster. At some point, x to the 15 does not catch up and becomes so tiny. It's like a constant now. While e to the x is already way ahead. So at some point it becomes constant over infinity, which is 0. Does it make sense? How cool is that? So I like to mention it's like if you have a black hole and there's a huge explosion in the side of the black hole, which one is going to win? The expansion out of the explosion or sucking into the nowhere out of the black hole? The speed matters. Which one is stronger? So supernova creates the expansion while black hole creates this suction. How do you call this word? I don't know. So which one wins? That's the ratio. The ratio of speeds matter. In this case, black hole won. Everything shrank to nothing. I mean, like, not physics point of view, right? That's how I see it. Log is the slowest one. You see log, it loses at infinity. Does it make sense? Unless there's something cool after that, yeah, log loses. So what's the answer? 0. Denominator is amazing again at infinity. Factorial, log, and e. That's when you need to know the speeds. E is super fast. Don't care about log, too slow. But factorial is faster at infinity. Again, not at minus infinity, not at 0. So in this case, infinity wins. Make sense? How cool is that? And then how about these guys? You stare at them a little bit. Only at infinity, remember. Find the leader of the top. I taught you this before. Find it at the bottom. Rare case, when the speeds are the same, up to the coefficients. The answer is minus 3 over 10. Isn't it cool? like all of these ideas. You don't have to do L'Hopital's rule because you're supposed to do L'Hopital rule here. Actually, you don't know derivative of x factorial. The derivative here, no. If you know the infinity speeds, you're good to go.
What's the derivative of x factorial?
Actually, I don't remember. Is it habit? X n factorial is not a continuous function because it works only with natural. So derivative cannot be defined since it has infinitely many gaps. X factorial exists, but it's defined in a really weird way. You have to Google to see how interesting. But it's usually natural numbers, because 1, 2, 3, 4, what is 7.5 factorial? Exactly. And that's why derivative there is not defined that simple. Very good question though. Good job, people.